July 15th, 1944, Aberdeen, Proving Ground, Maryland. The concrete pad reflected the morning heat as Sergeant First Class Tommy Rodriguez circled the most advanced amphibious vehicle ever captured from Nazi Germany. A Volkswagen Type 166 Schwimmwagen, dark yellow paint gleaming, 2,000 pounds of German engineering precision, the most produced amphibious car in history. Rodriguez dropped the propeller into place with a simple click. Direct drive from the crankshaft. No complex transmission, no separate marine engine, just pure German elegance that made American mechanics shake their heads in wonder. Jesus, Mary, and Joseph, whispered Corporal Murphy, staring at the portal hubs and locking differentials. This thing's got four-wheel drive better than our Jeeps. They fired it up, 800 RPM per. Up a 35% grade, no problem. Through 18 inches of mud, walked right through it. For 72 hours, Rodriguez and his team had one mission: determine if this German swimmer could replace 600,000 American Jeeps already in the field. Then they opened the hood, and everything they thought they knew about superior engineering was about to get turned upside down. Rodriguez adjusted his grip on the clipboard as the morning sun climbed higher over Aberdeen's test facility. The Schwimmwagen sat motionless on concrete pad 47, its amphibious propeller now secured in the dropped position. Behind him, 5 Detroit-trained mechanics waited with the practiced patience of men who had torn down everything from captured Italian motorcycles to German Tiger tanks. Their job was simple in concept, brutal in execution: determine whether this sleek German swimmer could replace the backbone of American military transport. Corporal Eddie Murphy, his coveralls already stained with hydraulic fluid from the morning's preliminary inspection, ran his hand along the vehicle's flank. "Tommy, look at this bodywork. No welds visible anywhere. This isn't stamped steel. It's formed aluminum over a steel frame." Murphy had supervised Ford assembly lines in Dearborn before the war, watching workers bolt together Jeep frames at the rate of one every 4 minutes. The German construction philosophy seemed to operate from an entirely different universe of manufacturing priorities. Rodriguez nodded toward the engine compartment. "Fire her up, Murphy. Let's see what 25 horsepower sounds like when it's not pushing a Jeep through Belgian mud." The air-cooled boxer engine turned over with a mechanical precision that made the assembled mechanics exchange glances. No rough idle, no valve chatter. 800 RPM, as steady as a Swiss timepiece. Rodriguez had heard enough Jeep engines to know the difference between adequate and exceptional, and this German power plant belonged in a different category entirely. Technical Sergeant Mary Catherine O'Brien approached the vehicle with a torque wrench and the methodical expression she wore when dissecting complex machinery. At 31, Mac had spent more time inside automotive transmissions than most men spent inside churches, and her reputation for diagnostic accuracy had earned her the transfer from Willow Run's bomber production lines to Aberdeen's enemy equipment evaluation section. "Rodriguez, check the differential housing. Those aren't standard ring and pinion gears." She pointed toward the portal gear hubs that lifted the entire drivetrain higher off the ground than conventional axle design would allow. The first driving test revealed capabilities that defied American expectations about light vehicle performance. Rodriguez engaged first gear and felt the all-wheel drive system activate automatically. No transfer case lever, no manual lockout procedure. The Schwimmwagen climbed Aberdeen's standard 35% test grade without wheel spin or engine strain. Through the 18-inch mud pit that regularly trapped lighter American vehicles, it maintained forward progress with an ease that bordered on insulting to domestic engineering pride. "Sweet Jesus," muttered Private First Class Danny Kowalski, Aberdeen's newest arrival from the Chrysler Tank Arsenal in Detroit. "This thing weighs 2,000 pounds and it's outperforming our 3,000-pound trucks." Kowalski had grown up believing American automotive superiority was a natural law, like gravity or thermodynamics. Watching German engineering contradict that belief in real time created the uncomfortable sensation of witnessing physics bend in unexpected directions. The amphibious demonstration commenced at 1400 hours in Aberdeen's test basin. Rodriguez lowered the Schwimmwagen down the concrete ramp until water reached the door sills, then engaged the propeller drive with a simple mechanical coupling. No complex hydraulics, no electrical systems to fail underwater. The vehicle transitioned from land to marine operation with the casual elegance of a design that had solved amphibious problems. American engineers were still struggling to understand. Murphy climbed into the passenger seat as Rodriguez guided the floating vehicle across the basin's choppy surface. 6 miles per hour forward progress, steering accomplished by the front wheels acting as rudders. Seaworthiness that handled 2-foot swells without taking on water. "Tommy," Murphy said, his voice carrying the wonder of a man witnessing technological magic, "we've been building amphibious vehicles wrong this whole time. Look at this freeboard. Look at this stability. Our GPA starts shipping water in anything rougher than a bathtub." The emotional weight of superior performance settled over Rodriguez like a lead blanket. His younger brother Miguel had died at Anzio when their Jeep company attempted to ford the Moleta River under German artillery fire. Standard American vehicles could wade through 30 inches of water before drowning their electrical systems and flooding their engines. Miguel's Jeep had made it halfway across before taking a direct hit from an 88mm shell, but Rodriguez always wondered whether better amphibious capability might have reduced the crossing time enough to matter. Captain James Harrison arrived at 1530 hours carrying a leather portfolio and the expression of a man preparing to deliver complicated news. At 34, Harrison bridged the gap between Aberdeen's grease-stained mechanics and Pentagon procurement officers who made decisions based on spreadsheets rather than field performance. His thick wire-rimmed glasses and former Chrysler engineering background gave him credibility with both communities, but Rodriguez could read the concern in Harrison's methodical approach to the afternoon's evaluation. "Gentlemen," Harrison announced, consulting his clipboard with deliberate precision, "we have received preliminary test results from British forces who captured similar vehicles during Normandy operations. Their mechanical assessment raises questions about maintenance requirements and parts standardization that we need to address before making any procurement recommendations." He paused, studying the Schwimmwagen with the analytical expression of an engineer who appreciated technical excellence while understanding its practical limitations. Rodriguez felt the first cold touch of reality intruding on the morning's technological wonder. 72 hours to evaluate whether German innovation could replace 647,000 American Jeeps already deployed across every theater of operations. The mathematics of that replacement, spare parts inventories, mechanic training programs, supply chain compatibility represented logistical challenges that no amount of engineering elegance could solve through pure performance superiority. The Schwimmwagen sat silent on its concrete pad as afternoon shadows lengthened across Aberdeen's test facility, its yellow paint gleaming with the promise of technological advancement and the hidden complexity that would define the next 3 days of American military engineering evaluation. Day 2 began with Technical Sergeant O'Brien methodically documenting measurements that told a story of German engineering philosophy fundamentally different from American mass production doctrine. The Schwimmwagen's portal gear hubs demonstrated a 6.2-to-1 gear reduction that distributed drivetrain stress across multiple components, reducing individual part failure rates by 40% compared to conventional solid axle designs. O'Brien's slide rule calculations filled 3 pages of technical specifications, each number representing manufacturing decisions that prioritized mechanical sophistication over production simplicity. Rodriguez positioned Ford's GPA Amphibious vehicle alongside the German swimmer for direct comparison testing. The American Seep weighed 3,500 pounds compared to the Schwimmwagen's 2,006 pounds, a difference that immediately translated into performance advantages across every category of evaluation. The German vehicle's lower ground pressure meant superior cross-country mobility through soft terrain that bogged down heavier American equipment. Its reduced mass allowed higher speeds through water and better handling characteristics in amphibious operations, where every pound of excess weight reduced freeboard and increased vulnerability. The morning's trials revealed technical innovations that challenged fundamental assumptions about light vehicle design. Murphy timed the Schwimmwagen's acceleration from 0 to 30 miles per hour, 14.6 seconds on Aberdeen's standard test course. The GPA required 19.2 seconds to reach the same speed, handicapped by its additional 1,500 pounds of armor plating and reinforced chassis components. Rodriguez recorded these numbers with growing appreciation for German engineers who had solved weight-to-performance ratios that American designers attacked through brute force horsepower increases. Captain Harrison arrived carrying copies of Technical Manual E3451, the classified handbook on German military forces that provided context for captured equipment evaluation. Page 416 specifically addressed the Kübelwagen family of vehicles, including detailed specifications for the Type 166 Amphibious variant. Harrison distributed sections to each mechanic, transforming individual observations into systematic analysis of German automotive doctrine and its compatibility with American military requirements. Mac O'Brien began her detailed transmission teardown at 0900 hours, documenting component specifications with the methodical precision that had made her indispensable to Aberdeen's evaluation teams. 16 precision machined parts comprised the Schwimmwagen's differential assembly, each component manufactured to tolerances measured in hundredths of millimeters, rather than the 16ths of inches standard in American production facilities. The German transmission case required exactly 1.4 quarts of specialized gear oil formulated specifically for portal hub lubrication, a specification that existed nowhere in American military supply manuals. The cross-country performance trials conducted on Aberdeen's obstacle course demonstrated capabilities that made American mechanics question their understanding of what light vehicles could accomplish. The Schwimmwagen climbed grades that stopped conventional Jeeps, forded streams that flooded American electrical systems, and maintained stability over terrain that would roll less sophisticated four-wheel drive designs. Its independent suspension system and portal gear ground clearance allowed navigation through rocky terrain that required careful route selection in standard military vehicles. Rodriguez documented maintenance intervals that revealed the hidden complexity behind German engineering excellence. The air-cooled engine demanded oil changes every 500 miles compared to 1,000-mile intervals for water-cooled American engines. The sophisticated air filtration system required complete disassembly and cleaning every 50 miles in dusty conditions, a procedure that consumed 47 minutes with proper German tools, but proved nearly impossible with standard American field equipment. Each maintenance advantage came with corresponding logistical penalties that multiplied across thousands of vehicles in operational deployment. Murphy calculated the arithmetic of battlefield logistics while observing the Schwimmwagen's superior performance characteristics. Manufacturing cost estimates based on similar German captured equipment analysis suggested a per-unit price of approximately $1,847 compared to the Jeep's $648 production cost. Training requirements for mechanics qualified to service portal gear hubs and air-cooled engines averaged 80 hours compared to 12 hours for standard Jeep maintenance certification. The specialized knowledge required to keep Schwimmwagens operational represented human resource investments that strained military training capacity beyond sustainable limits. The afternoon amphibious trials in Chesapeake Bay provided the most dramatic demonstration of German technological superiority and its practical limitations. The Schwimmwagen handled 2-foot swells that swamped Ford's GPA, maintaining stability and forward progress through conditions that rendered American amphibious vehicles inoperable. Its watertight hull design and optimal weight distribution created seaworthiness characteristics that impressed even experienced Navy personnel observing the trials from Aberdeen's marine testing facility. O'Brien's detailed parts inventory revealed 47 components unique to German manufacturing specifications, from specialized electrical connectors rated for 6-volt systems to transmission seals designed for metric threading that had no American equivalent. The supply chain implications staggered logistics officers accustomed to standardized parts compatible across multiple vehicle platforms. Each specialized component created potential single points of failure that could immobilize entire motor pools when replacement parts became unavailable through normal military procurement channels. The day's final evaluation focused on operational doctrine compatibility, examining whether German engineering solutions addressed American tactical requirements or merely demonstrated alternative approaches to similar problems. Captain Harrison led discussions that revealed fundamental philosophical differences between German precision manufacturing and American mass production strategies. The Schwimmwagen represented engineering optimization for specific performance parameters, while American military vehicles prioritized standardization, maintainability, and production scalability across multiple manufacturers and supply chains. Rodriguez concluded the second day's testing with profound respect for German technical achievement and growing concern about its practical application to American military requirements. The numbers documented superior performance across multiple categories, but each advantage carried corresponding complexity that threatened the logistical simplicity upon which American military success depended. The Schwimmwagen's excellence existed within narrow parameters that might not survive the brutal realities of global warfare conducted across multiple theaters simultaneously. Day 3 arrived with Captain Harrison distributing manufacturing analysis reports that transformed technical admiration into cold arithmetic reality. O'Brien spread her detailed cost calculations across the conference table, each column of figures representing industrial capacity requirements that strained American production philosophy beyond practical limits. Retooling existing assembly lines for Schwimmwagen production would consume $2.7 million per manufacturing facility, compared to $340,000 required for amphibious Jeep variants using existing component inventories and worker skill sets. Rodriguez studied supply chain compatibility charts that revealed the fundamental incompatibility between German precision manufacturing and American mass production doctrine. The Schwimmwagen's 47 specialized components required dedicated supply lines reaching back to specific German industrial facilities, many of which Allied bombing campaigns had already destroyed or damaged beyond operational capacity. American military logistics depended upon interchangeable part standards that allowed field mechanics to cannibalize components from multiple vehicle types, creating redundancy that German engineering precision actively prevented through tight manufacturing tolerances. The morning's maintenance trials provided brutal confirmation of logistical nightmares hidden beneath German technical excellence. Murphy attempted routine engine service using standard American field tools, documenting procedures that consumed 4 hours and 23 minutes compared to 31 minutes required for identical maintenance on conventional Jeeps. The Schwimmwagen's air-cooled engine demanded specialized wrenches sized to metric specifications, oil filters requiring German-specific removal tools, and adjustment procedures calibrated to European measurement standards that existed nowhere in American technical manuals. O'Brien calculated training requirements for mechanics qualified to service captured German vehicles across multiple theaters of operations. 80 hours of specialized instruction per technician, multiplied by existing motor pool personnel. Strength created educational demands that exceeded available training facility capacity by 300%. The mathematical reality eliminated any possibility of widespread Schwimmwagen adoption regardless of performance advantages, since American forces lacked sufficient qualified personnel to maintain existing captured equipment inventories at sustainable operational levels. The afternoon's amphibious trials in Chesapeake Bay revealed payload limitations that undermined the Schwimmwagen's tactical utility despite its superior seaworthiness characteristics. Maximum safe load capacity measured 959 pounds, insufficient for a fully equipped American infantry squad carrying regulation weapons, ammunition, radio equipment, and personal gear totaling 1,240 pounds. The German vehicle sat dangerously low in rough water when loaded to American operational standards, taking on spray that threatened electrical systems and reducing freeboard to unsafe margins during contested river crossings under enemy fire. Rodriguez conducted range calculations that exposed the Schwimmwagen's fatal weakness in American tactical doctrine, emphasizing speed and survivability over technical sophistication. 6 miles per hour maximum water speed meant 30 minutes exposure time crossing a 3-mile river, creating vulnerability windows that guaranteed casualties under artillery observation or machine gun coverage. American Amphibious doctrine demanded rapid crossing capabilities that minimized exposure time through higher speeds and reduced crossing duration, tactical requirements that German engineering excellence could not address through superior craftsmanship alone. Captain Harrison reviewed field reports from British forces who had captured and operated Schwimmwagens during Normandy operations, documentation that provided operational context for Aberdeen's technical evaluations. British tank crews praised the vehicle's cross-country performance and mechanical reliability, but noted their complete inappropriateness for frontline military service. German officers used captured Schwimmwagens primarily for reconnaissance duties and recreational hunting expeditions behind secure lines, applications that exploited their technical sophistication while avoiding their tactical limitations. The final maintenance evaluation revealed the decisive factor that eliminated any possibility of American adoption, regardless of performance characteristics. Complete engine service under simulated combat conditions required 2 hours and 47 minutes using proper German tools and procedures, compared to 31 minutes for identical service on standard Jeeps using field expedient methods and improvised equipment. The time differential meant Schwimmwagen-equipped units would spend nearly 3 times longer in vulnerable static positions during routine maintenance, creating tactical disadvantages that negated any performance benefits gained through superior engineering. Murphy documented part standardization incompatibilities that created logistical vulnerability extending far beyond individual vehicle maintenance requirements. German electrical components operated on 6-volt systems incompatible with 12-volt American standards, requiring separate battery inventories, charging equipment, and replacement parts that shared no commonality with existing military stockpiles. Transmission lubricants, hydraulic fluids, and specialized compounds necessary for German vehicle operation demanded dedicated supply chains reaching across Atlantic shipping lanes already strained beyond capacity by existing military requirements. Rodriguez completed his evaluation thinking of Miguel's death at Anzio and the hard-learned lessons about battlefield survival that German technical elegance could not address. American tactical doctrine prioritized overwhelming material superiority achieved through standardized equipment that semi-skilled personnel could maintain under combat conditions using basic tools and improvised procedures. The Schwimmwagen represented automotive artistry that demanded skilled craftsmen, specialized facilities, and peacetime maintenance schedules, incompatible with global warfare's brutal realities. O'Brien's manufacturing analysis provided the final verdict through mathematical precision that eliminated emotional arguments about technical superiority. American industry could produce 6 conventional amphibious jeeps in the time required to manufacture one Schwimmwagen using existing tooling, worker training, and supply chain infrastructure. The arithmetic of industrial warfare demanded quantity production that overwhelmed enemy forces through numerical superiority rather than individual technical excellence, strategic priorities that German engineering philosophy fundamentally misunderstood. The day concluded with Captain Harrison drafting preliminary recommendations that would guide American military procurement policy for decades beyond the war's end. German innovation demonstrated advanced engineering concepts that proved unsuitable for American adoption due to logistical complexity and manufacturing requirements incompatible with mass production doctrine. The Schwimmwagen's technical brilliance created beautiful machinery that failed completely when measured against American military requirements for standardization, maintainability, and production scalability across global theaters of operations. Rodriguez secured the test vehicle as afternoon shadows lengthened across Aberdeen's evaluation facility. His respect for German craftsmanship tempered by understanding that superior engineering meant nothing when it could not be sustained under combat conditions by ordinary soldiers using standard equipment and basic training. Aberdeen's marine testing facility prepared for the final amphibious trials that would determine whether German engineering excellence could survive American tactical reality. Captain Harrison positioned observation teams along Chesapeake Bay's shoreline as Rodriguez guided the Schwimmwagen down the concrete launch ramp into 15-knot winds and 18-inch swells that simulated contested beach landing conditions. The morning's evaluation would test payload capacity, seaworthiness, and operational speed under combat representative scenarios that revealed the gap between laboratory performance and battlefield requirements. Murphy climbed into the passenger seat carrying full combat equipment that replicated standard American infantry loadouts. M1 Garand rifle, ammunition belt, radio equipment, medical supplies, and personal gear totaling 287 pounds per man. Rodriguez added his own equipment load plus additional ammunition and communications gear required for squad-level operations, bringing total cargo weight to 1,240 pounds. The Schwimmwagen settled noticeably lower in the water, reducing freeboard to margins that concerned experienced Navy personnel observing from Aberdeen's Marine Operations Center. The vehicle launched into Chesapeake Bay's choppy surface with seaworthiness characteristics that initially impressed military evaluators accustomed to American amphibious equipment limitations. Its watertight hull design handled moderate swells without shipping water, while the front-wheel steering system provided directional control superior to conventional propeller-driven craft of comparable size. Rodriguez maintained forward progress at 6 miles per hour through conditions that would swamp Ford's heavier GPA, demonstrating German engineering's genuine advantages in specialized operational environments. O'Brien timed the crossing simulation that revealed the Schwimmwagen's fatal tactical weakness despite its superior technical performance. 3 miles of open water at 6 miles per hour Maximum speed meant 30 minutes of exposure time under hypothetical enemy observation and artillery fire. American Amphibious Doctrine demanded rapid crossing capabilities that minimized vulnerability through speed rather than seaworthiness, tactical priorities that German engineering excellence could not address through superior craftsmanship alone. The mathematical reality eliminated operational utility regardless of technical sophistication. Wave conditions deteriorated as the morning trial progressed, creating 18-inch swells that tested payload capacity against seaworthiness in realistic combat scenarios. The fully loaded Schwimmwagen began taking spray over the bow, threatening electrical systems and reducing stability margins to dangerous levels. Rodriguez struggled to maintain directional control as shifting cargo weight affected the vehicle's trim, demonstrating that German engineering optimization for reconnaissance missions could not accommodate American tactical requirements for heavy equipment transport. During contested river crossings, Captain Harrison monitored radio communications between the test vehicle and shore-based observers, documenting performance degradation as operational conditions exceeded German design parameters. The Schwimmwagen's sophisticated engineering provided excellent performance within narrow specifications, but American military doctrine demanded equipment capable of handling extreme conditions with generous safety margins built into operational planning. German precision manufacturing created beautiful machinery that failed catastrophically when pushed beyond intended limitations, philosophical differences that reflected fundamental incompatibilities between European and American approaches to military equipment design. The return crossing provided definitive evidence of tactical unsuitability, despite continued technical excellence. Rodriguez reduced cargo load to 800 pounds, bringing the vehicle within German design specifications and restoring acceptable freeboard margins. Performance immediately improved, demonstrating that the Schwimmwagen functioned superbly when operated according to German tactical doctrine, emphasizing light reconnaissance and specialized missions rather than general-purpose transportation roles demanded by American military organization. Murphy documented maintenance requirements under simulated combat conditions that revealed the decisive factor eliminating any possibility of American adoption. Complete engine service using German tools and procedures consumed 2 hours and 47 minutes compared to 31 minutes required for identical maintenance on conventional Jeeps using field expedient methods. The time differential meant Schwimmwagen-equipped units would remain vulnerable in static positions nearly 3 times longer during routine maintenance, creating tactical disadvantages that negated performance benefits gained through superior engineering. O'Brien calculated supply chain requirements for sustained Schwimmwagen operations across multiple theaters simultaneously, mathematical analysis that exposed logistical impossibilities hidden beneath German technical achievement. Specialized parts inventory, metric tooling requirements, and trained personnel demands exceeded American military capacity by factors measured in hundreds of percent rather than manageable increments. The arithmetic of global warfare eliminated German innovations regardless of individual technical merit when multiplied across divisions, corps, and army-level deployment requirements. The afternoon concluded with Rodriguez conducting final performance evaluations that confirmed his emotional reconciliation with Miguel's death at Anzio. American tactical doctrine prioritized equipment that ordinary soldiers could operate and maintain under combat conditions using basic training and standard tools. Strategic philosophy that emphasized reliability over sophistication. The Schwimmwagen represented automotive artistry that demanded skilled operators and peacetime maintenance schedules incompatible with battlefield reality, where 19-year-old mechanics from Iowa performed critical repairs using crescent wrenches and determination. Captain Harrison reviewed British field reports documenting actual Schwimmwagen employment by German forces during combat operations, intelligence that provided operational context for Aberdeen's technical evaluations. Wehrmacht officers used the vehicles primarily for hunting expeditions and reconnaissance duties behind secure lines, applications that exploited their technical sophistication while avoiding tactical limitations that made them unsuitable for frontline military service. The gap between German engineering capability and American operational requirements represented philosophical differences that no amount of technical excellence could bridge through superior craftsmanship. The final evaluation session revealed the Schwimmwagen's tragic perfection. Every innovative solution created dependency. Every precision component became a potential failure point, and every clever design decision demanded specialized knowledge that existed nowhere in American military training programs. Rodriguez secured the test vehicle as evening shadows fell across Aberdeen's facility, understanding that German engineering had produced magnificent machinery completely unsuited for American military requirements, despite its undeniable technical superiority in specialized applications. August 10, 1944. Conference Room B at Aberdeen Proving Ground, filled with the quiet tension that accompanied final military procurement decisions, affecting thousands of lives and millions of dollars in industrial capacity. Colonel Robert Patterson entered carrying the complete evaluation files, his expression revealing nothing of the conclusions that would guide American military vehicle doctrine for the remainder of the war and decades beyond. At 48, Patterson had supervised enough captured equipment analyses to understand that superior engineering meant nothing when measured against logistical reality and strategic requirements. Rodriguez sat with his evaluation team around the polished conference table, watching Pentagon procurement specialists and Ford Motor Company engineers review technical documentation that transformed 3 days of hands-on testing into institutional policy. The room contained men who made decisions affecting production lines in Detroit, supply chains crossing the Atlantic, and maintenance procedures performed by mechanics from Normandy to the Pacific Theater. Each recommendation would ripple through American military organization in ways that individual performance specifications could never capture. Captain Harrison presented the technical findings with methodical precision that eliminated emotional arguments about German engineering excellence. The Schwimmwagen demonstrated undeniable innovation in portal gear design, amphibious propulsion systems, and weight-to-performance ratios that surpassed American equivalent vehicles across multiple categories of evaluation. Its sophisticated manufacturing reflected German industrial philosophy, prioritizing precision craftsmanship over mass production efficiency, engineering decisions that created beautiful machinery unsuited for American military requirements. O'Brien's manufacturing analysis provided the mathematical foundation for institutional decision-making that transcended individual vehicle performance characteristics. Retooling costs of $2.7 million per production facility exceeded American industrial capacity allocation for specialized equipment programs. Training requirements consuming 80 hours per mechanic multiplied across existing motor pool personnel created educational demands that strained military instruction facilities beyond sustainable limits. The arithmetic eliminated German innovations regardless of technical merit when applied to global warfare requiring standardized equipment and simplified maintenance procedures. Patterson reviewed field intelligence reports from British forces operating captured Schwimmwagons in combat theaters, documentation that provided operational context for Aberdeen's laboratory evaluations. Royal Tank Regiment personnel praised the vehicle's cross-country performance and mechanical sophistication while noting their complete inappropriateness for military service, demanding reliability over elegance. German officers employed Schwimmwagens primarily for recreational hunting and reconnaissance duties behind secure lines, applications that exploited technical advantages while avoiding tactical limitations that made them unsuitable for frontline operations. The procurement officers examined supply chain compatibility studies that revealed fundamental incompatibilities between German precision manufacturing and American logistics doctrine. 47 specialized components required dedicated supply lines reaching to specific European industrial facilities, many destroyed by Allied bombing campaigns or occupied by advancing Soviet forces. American military success depended upon interchangeable part standards that allowed field mechanics to improvise repairs using components from multiple vehicle types, redundancy that German engineering actively prevented through tight manufacturing tolerances and metric specifications. Rodriguez presented maintenance timing comparisons that provided decisive evidence against Schwimmwagen. Adoption despite acknowledged performance superiority. Complete engine service under combat conditions consumed 2 hours and 47 minutes, using proper German tools compared to 31 minutes for identical maintenance on standard Jeeps using field expedient procedures. The time differential created tactical vulnerability that negated any operational advantages gained through superior engineering, exposing units to enemy action during extended maintenance periods that American doctrine specifically avoided through simplified equipment design. Major William Henderson from Pentagon Procurement reviewed cost-benefit analyses that transformed technical admiration into strategic decision-making based on industrial capacity and resource allocation priorities. American war production demanded maximum output from existing manufacturing infrastructure rather than conversion to specialized equipment requiring new tooling, worker training, and supply chain development. The Schwimmwagen represented automotive artistry that conflicted with mass production philosophy, emphasizing quantity over individual technical excellence. Strategic priorities that determined victory through overwhelming material superiority rather than equipment sophistication. Captain Harrison read excerpts from captured German technical manuals that revealed the philosophical gap between European precision manufacturing and American industrial doctrine. Wehrmacht technical specifications demanded skilled craftsmen, specialized facilities, and peacetime maintenance schedules that assumed access to original equipment manufacturer support networks. American military equipment design prioritized operation and maintenance by semi-skilled personnel using basic tools under combat conditions, engineering philosophy that emphasized reliability over sophistication in recognition of battlefield reality. The final discussion addressed payload limitations that undermined Schwimmwagen tactical utility despite superior seaworthiness characteristics. Maximum safe carrying capacity of 959 pounds proved insufficient for fully equipped American infantry squads totaling 1,240 pounds, including weapons, ammunition, radio equipment, and personal gear. German engineering optimization for light reconnaissance missions could not accommodate American operational requirements for heavy equipment transport during contested operations, tactical incompatibilities that eliminated adoption regardless of technical performance advantages. Patterson signed the final recommendation with institutional understanding that sometimes adequate solutions working everywhere defeated perfect solutions, working only under ideal conditions. German Type 166. Schwimmwagen demonstrated advanced engineering concepts unsuitable for adoption by American forces due to logistical complexity and manufacturing requirements incompatible with mass production doctrine and global deployment demands. The decision reflected strategic wisdom prioritizing sustainable industrial capacity over individual technical achievement, lessons that would guide American military procurement policy throughout the Cold War and beyond. Rodriguez collected his evaluation notes as the conference concluded, finding peace in understanding that Miguel's death at Anzio resulted from tactical circumstances rather than American technical inadequacy. The Jeep design philosophy emphasized simplicity, maintainability, and production scalability that enabled global warfare through overwhelming logistical superiority rather than individual equipment excellence. By war's end, American industry had produced 647,925 Jeeps compared to Germany's 15,584 Schwimmwagons. Mathematical testimony to strategic priorities that determined victory through industrial capacity rather than engineering sophistication.